All right, here's a triangle. What we're going to do is something similar to what we did yesterday. Remember we did the circumcenter yesterday? The circumcenter, how did you find the circumcenter? You may want to keep a little running list because there's about 4 of these. We're only going to do 2, one yesterday, one today, but then we're going to do a couple in the next lesson. So what'd you have to find? What'd you do to the sides of the triangle to find the circumcenter? Find the what? Say it.
You made perpendicular.
Perpendicular what? Bisector, right? Perpendicular bisector of the sides, right? Today what we're going to learn is we're going to learn another one, and it's called the incenter. All right, and this time we're not going to do the perpendicular bisector. What did we just talk about? Doing what to the angle? Bisecting the angle, that's right. Okay, so I'm going to say angle bisector. You see that? So to find the circumcenter, you take the sides and you do the perpendicular bisector of the sides. You might want to jot that down. To find the incenter, what you do is you take the angle bisector. So you bisect the angles. All 3 of those angle bisectors should come together to a point. All right? It means they're concurrent. If they come together to a point, and we're going to see what's true about that point. So let's try this. Now again, we're going to have to eyeball the angle bisector. I don't really have a way, I don't think anyway, to do it other than just looking. Does that look like it's about bisecting that angle?
A little bit up. A little bit.
Well, remember, we're not bisecting the side. I'm not saying we're trying to find the midpoint of the side. I'm looking at the angle, this angle right here. That's what you're looking at. You're not looking to see where it hits the other side. That makes no difference, okay? Because that's what some of the kids in the other class were saying. We're like, oh, that's not right in the middle. Well, I'm not looking to see what's in the middle of this side necessarily, okay? I'm looking at this angle. Do you see? Watch, this angle goes from here to here, doesn't it? Tell me when it hits it in the middle. Not the middle of the side, but the angle itself.
I think that's what I did.
Right in there somewhere? Okay, that's pretty close. All right. So that's one angle bisector. Let's take this angle right here and let's bisect it. So what do you think? A little higher? Lower? Maybe about right in there somewhere? Does that look pretty close? Okay, does that look like it bisects it? Let's do it here. Now, I might have to fudge just a little bit. You know what I mean? I might have to, oops, I don't want that.
You can just go.
Because, watch. It will hit the center, so hopefully that's the bisector. Does that look like it bisects that angle up there? Yeah, it's pretty close, isn't it? Now again, if I had a protractor and I was able to measure these things out, I could do it a lot more accurately. I'm just trying to eyeball it. I'm just trying to look. And look what happens. All 3 of those angle bisectors, they meet at one point. So that means those 3 lines are concurrent lines, aren't they? Now, this point that they meet at, what do you think we call it? The incenter. So this point right here is called the incenter of this triangle. How do we find the incenter? We take the angle bisectors, and where they meet, that's going to be the incenter.
Can we look for the circumcenter just to see how different it looks like?
We could if we have some time, but let's do this first before we mess the whole thing up, okay? Because it'll be a little bit messy in here. Now, what did we say about the circumcenter? Remember when you did the perpendicular bisector, it met at some point? We said it was equidistant from the 3 points, right? From the 3 vertices.
Oh, yeah.
But this right here, it's not going to be equidistant from the 3 vertices. So if I just did what you... Watch. This distance right here, and this one here, and this one here. They're not going to be the same lengths, are they? Because look, that length is way shorter than this one, isn't it? Okay? But what it is this. Watch. It's equidistant from the sides of all 3 sides of the triangle. So it's equidistant from all 3 sides of the triangle. So what is the distance from a point to a line segment? It's perpendicular, isn't it? All right, so that's perpendicular here. Where's perpendicular here? About like that? Is that pretty close to right angle? It's close, isn't it?
The bottom one isn't.
Yeah, the bottom one is. It's perfectly close because I hit shift and shift makes it perpendicular. I just can't do that to these because these are already at a slant. All right, so it kind of looks like right on that red line, doesn't it? I'll tell you what, I'm just going to go off it just a little bit just to show. It doesn't have to be along one of those lines, okay? Now watch. Look at the blue lines. Look at that one, look at this one, and look at this one. All 3 of them, if you do everything just right, should be equal to each other. Now remember what they are. It's the distance from a point to a line, so they must all be perpendicular. Would you agree? All right, so all three of those lines must be equal to each other. So that's what an incenter does. The incenter is equidistant from the three sides of the triangle. Everybody see that? So the incenter is equidistant from the three sides of the triangle. The circumcenter would be what? Equidistant from the three, don't say angles. What? Vertices. The vertices, right. Okay, the vertices. So the circumcenter is equidistant from the three vertices. The incenter is equidistant to the three sides of the triangle. Do you see the difference between that? All right. Maddie Fresh over here wants to, what would be a good color?
Purple.
Is the purple going to blend in this purple?
Yeah, magenta.
Magenta? Okay.
Yeah.
Let's do this. Let's, again, we got to eyeball this a little bit, but, we can actually do this. So it's right here. So what we're going to do is we're going to go in purple, but what are we doing this time? Matt wants to do this, so can you see a difference? No, that's black.
Let's do rainbow, because
Nah, rainbow. Let's go, let's go like this light green.
Yeah, it looks fresh.
Can you see it?
Yeah.
Okay. All right, so what are we doing now? Just to see the difference between the incenter and the circumcenter. It's a perpendicular bisector, isn't it?
Mm-hmm.
All right. Now I know that's the only one that's actually close, but let's see this. If I come over here like that, that should be the center, right? And we're going to go perpendicular, so that should be about right in here somewhere. I don't know. That's close enough.
And on an isosceles triangle, the perpendicular would both be the same, right?
Now, why didn't that go back to green? I must have touched something else. Okay, so there you go. And then we got to find the middle of this. Oh, I know why, because I clicked on that thing. So middle of this would be about right in here. Does that look about the middle?
Yeah.
Okay, we go perpendicular. And it's about right there. And again, I got to make it green. All right, so this right here would be the circumcenter. You see that?
Mm-hmm.
So the little green one is the circumcenter. The red one is the incenter. The circumcenter would be what? It would be equidistant from the three vertices. So if I took a line, let's go different color again. I told you it would be a mess, didn't I? We'll go to the magenta. Watch. If I took a line and I went to here, and I went to here, and I went to here. Getting confused yet?
I'm so confused.
All right, so those purple ones right here.
Look at all the yummy triangles.
Yeah. Okay, the purple right here, look at those three lengths. They should be the same. All right?
You can do so many math
That's pretty cool.
Triangle,
Yep.
Look at the beautiful
All right, well, I didn't really mean to get into that mess, okay? I didn't mean to put both of them in one triangle because you can see it definitely gets a little ugly.
You're
But
welcome, YouTube.
anyway, there's the circumcenter and there's the incenter, right? And that's how you find it. Okay? That's all I got for you today.